Welcome to students and viewers. In this video, we will discuss some important properties of isosceles triangles. Now let us discuss theorem 1 first. In an isosceles triangle, the angles opposite to equal sides are equal. Now in this triangle ABC, these two sides AB and AC are equal. We have to prove that angles opposite to equal sides, that means these two angles are equal. So we were given AB equal to AC. To prove that angle B equal to angle C, right? Now to prove this, we will draw a construction here. Let us join the median from the vertex A. Let's say this is the median on BC from the vertex A, right? So let us join midpoint of BC with A. AD is joined. So this is the midpoint of BC, means BD equal to DC. Now see, in these two triangles, AB equal to AC, BD equal to DC, and AD is a common side for both triangles, right? So in triangles ABD and ACD, we find that AB equal to AC, this is given, right? Then BD equal to CD, since D is the midpoint of BC. This is the midpoint of BC. Then again we find that AD equal to AD. It's a common side. Therefore, these two triangles ABD congruent to triangles ACD. By which criterion? SSS. Right? Three sides of this triangle are equal to three sides of this triangle. So these two triangles are congruent. Now we know that in congruent triangles, corresponding parts are equal. So corresponding angle of ABD is here ACD. Angle ABD equal to angle ACD by virtue of CPCT, corresponding parts of congruent triangles. Now what is ABD? Angle ABD means angle B in triangle ABC. Angle ACD means angle C in triangle ABC. So this was to be proved, right? Now let us prove another theorem here. If in a triangle two angles are equal, then their opposite sides are equal. Suppose you are given these two angles are equal, then this is, in this triangle, these two sides will be equal. That means this triangle will be isosceles triangle, right? So you are given angle B equal to angle C. To prove AB equal to AC. That means sides opposite to equal angles are equal. Again we will draw a construction here. Let us join this line AD. Say AD is a bisector of angle A, suppose. That means these two angles are equal. So let us draw bisector of angle A which intersects BC at D, the line segment BC at D. So AD is a bisector of angle A, and AD intersects BC, line BC at D. Now we see, now in triangles ABD and ACD, you see in these two triangles, you see we are given angle B equal to angle C. That means angle ABD equal to angle ACD. Since angle B equal to angle C, angle B means in this triangle ABD, angle C means for this triangle ACD. So these two angles are equal, right? Then we find angle BAD angle equal to angle CAD. Since AD is the bisector of angle A, AD is the bisector of angle A, right? So these two angles are equal. Then we find that AD equal to AD. It's a common side, right? Therefore, in these two triangles, we find that two angles and one side, which is not included by these two angles, are equal to two angles and one side of this triangle. So these two triangles are congruent by AAS criteria. Therefore, triangle ABD congruent to triangle ACD by AAS criteria. Two angles and one side. This side is not included by these two angles. Angle ABD and angle BAD. And this side AD is not included by these two angles. So this is called AAS criteria. So these two triangles are congruent. Now we know that in congruent triangles, corresponding parts are equal. Therefore, AB equal to AC. CPCT. That means triangle ABC is an isosceles triangle. So we conclude here that if we find that in a triangle two angles are equal, then their opposite sides are equal. That means that would be an isosceles triangle. Now let us solve some problems based on these two theorems here. In an isosceles triangle ABC, AB equal to AC, you are given AB equal to AC. It is an isosceles triangle. AB equal to AC, it is given. Bisectors of angle B and C intersect each other at O. Let us draw the bisector of angle B and bisector of angle C, suppose this line. They intersect each other at point O. Then join A to O. This is joined. So that OB equal to OC, we have to prove that this line segment equal to this line segment, OB equal to OC. And we also prove that AO is the bisector of angle A. AO is the bisector of angle A. That means these two angles will be equal. We have to prove that, right? So let us prove this. So we are given that AB equal to AC, given. So it's an isosceles triangle. In an isosceles triangle, the angles opposite to equal sides are equal. Therefore, angle ABC equal to angle ACB. Angles opposite to equal sides. Angles opposite to equal sides are equal. Therefore, angle ABC equal to angle ACB. Now, you see, angle bisector of angle B and C intersect each other at O. Bisector. OB is a bisector of angle B. OB bisects angle B and OC bisects angle C. You know, bisect ABO equal to OBC. These two angles are equal. Similarly, angle ACO equal to angle OCB. OB bisects angle B, that means these two angles are equal. Similarly, OC bisects angle C, that means these two angles are equal. Now we know that ABC equal to ACB. Now ABC means angle ABC equal to angle ABO plus angle OBC. That means angle OBC plus angle OBC. Since ABO equal to OBC, so in place of ABO we are writing OBC. That means twice of OBC. Angle ABC equal to twice of OBC. So we find that OBC equal to half of angle ABC. Right? OBC, this angle equal to half of angle ABC. Similarly, angle OCB equal to half of angle ACB. Right? So we find that OBC equal to half of ABC. Similarly, OCB, this angle equal to half of angle ACB. Therefore, angle OBC equal to angle OCB. Why? Since angle ABC equal to angle ACB. These two angles are equal. So their halves will be equal. Right? OBC equal to OCB. Therefore, OB equal to OC. We know that in a triangle, if two angles are equal, then their opposite sides are equal. Therefore, in triangle OBC, we find that angle OBC equal to angle OCB, like this. OBC, these two angles are equal, so their opposite sides are equal. Therefore, OB equal to OC. Reason is sides opposite to equal angle. Sides opposite to equal angles are equal. So one thing is proved. Now we have to prove that AO bisects angle A. AO, this line bisects angle A. That means these two angles are equal. Now you see in these two triangle, we find that OB equal to OC. This is already proved. OB equal to OC. AB equal to AC. It was given. Then we also find that these two angles are equal since they are half of equal angles. Right? Now in triangles ABO and ACO, we find that AB equal to AC, OB equal to OC. These are given. This is already proved, right? OB equal to OC, AB equal to AC is already given. Then we find that angle ABO equal to angle ACO, since they are halves of equal angles. Since they are halves of equal angles. They are halves of equal angles. So we find that in these two triangles, two sides and included angle equal to two sides and included angle of other triangle. So they are congruent. Therefore, triangle ABO congruent to triangle ACO by SAS criterion. Right? By SAS criterion, these two triangles are congruent. Now in congruent triangles, we know that corresponding parts are equal. Therefore, angle BAO equal to angle CAO by virtue of CPCT. Corresponding parts of congruent triangles are equal. So these two triangles are in these two angles are equal. Their corresponding parts. Why? Because OB equal to OC. Their angle opposite to OB is angle BAO. Angle opposite to OC is angle CAO. So BAO equal to CAO by virtue of CPCT. Now what is BAO equal to CAO mean? That means OA bisects angle A. That is OA bisects angle A. This was to be proved, right? Now let us come to question number 2 here. In triangle ABC, AD is perpendicular bisector of BC. In triangle ABC, AD is perpendicular bisector. That means these two angles are right angles, and also BD equal to DC, perpendicular bisector. So that triangle ABC is an isosceles triangle in which AB equal to AC. That means we have to prove that AB equal to AC. So you are given BD equal to DC, and AD perpendicular to BC. Line segment AD is perpendicular to BC. To prove AB equal to AC. That means triangle ABC is an isosceles triangle. Now you see, in triangles ABD and ACD, in these two triangles you find that BD equal to CD. It is given, right? Then AD equal to AD. It is a common side. Then you find that ADB equal to ADC. Since each of them will be 90 degree, because it's a perpendicular bisector, AD perpendicular to BC. So ADB equal to ADC. They are right angles, right? Therefore, triangle ADB congruent to triangle ADC by SAS, side angle side. Two sides and included angle. Here also two sides and included angle. They are equal. So by SAS criterion, these two triangles are congruent. Now in a congruent triangle, corresponding parts are equal. AB equal to AC by virtue of CPCT. Corresponding parts of congruent triangles are equal.